Welcome to Summarize Science, where we break down complex discoveries into bite-sized stories. Today, we are looking at a star system called AZV75, located about 200,000 light-years away in the Small Magellanic Cloud. This isn't just any star. The primary star is an early O-type star, which means it is incredibly hot, massive, and powerful. These massive stars act like the engines of their galaxies, pouring out radiation and heavy elements that eventually form new planets. One of the most important features of these giants is their stellar wind, a constant stream of particles flying off the star at incredible speeds. For years, scientists have used computer models to guess how large these wind regions are, but they had never actually measured one until now. The researchers discovered that AZV75 is actually a binary system, meaning it consists of two stars orbiting each other. Because they orbit at a specific angle from our perspective, they can be used as a perfect cosmic measuring tool. As the secondary star moves behind the primary star, it is eclipsed not just by the star itself, but by the primary star's invisible wind. By tracking how certain types of ultraviolet light were blocked during this transition, the team could see the physical shadow of the wind. This revealed that the wind formation region for this specific star extends up to 316 times the radius of our own Sun. This is a massive area, far larger than the star itself, where particles are being accelerated to their final, extreme speeds. To gather this data, the team combined information from the TESS planet-hunting satellite and the Hubble Space Telescope. Hubble's unique ability to see ultraviolet light was crucial because that is where the chemical signatures of the wind are most obvious. They specifically looked at elements like carbon and nitrogen moving within the high-speed flow of the wind. The data showed that the wind is incredibly thick and opaque to certain wavelengths of light, effectively acting as a screen. One of the most surprising findings involved the velocity law, or the rule for how fast the wind speeds up as it moves away from the star. The real-world measurements suggested the wind accelerates much faster than many current theories had previously predicted. This means our computer simulations of how massive stars evolve and age might need a significant update to be accurate. Understanding these winds is vital because they determine how much mass a star loses before it eventually explodes as a supernova. If a star loses mass differently than we thought, it changes the kind of black hole or neutron star it might leave behind. The researchers also noticed that the nearby companion star might be heating up the primary star's wind as it passes through. This creates a complex, swirling environment that was previously impossible to see in such high detail. To recap, this study provided the first-ever direct measurement of a massive star's wind-forming region. They proved that these winds are vast, reaching out hundreds of millions of kilometers into space around the star. The findings show that these winds behave more aggressively and accelerate faster than standard models once suggested. This discovery gives astronomers a new, solid benchmark to test their future theories and models against. In the future, this wind eclipse method could be used to map out even more stars across the distant reaches of the universe. It brings humanity one step closer to understanding the spectacular life cycles of the biggest stars in the cosmos. Thanks for watching Summarize Science, and stay curious about the wonders of our universe.